Hello, this is AP Chemistry, Chapter 2, Atoms and Elements. Section 2.5 goes over the structure of the atom. Radioactivity is the emission of small energetic particles from the nucleus of unstable atoms. Radioactivity can be alpha, beta, or gamma. And these are little particles that come out of the nucleus of the unstable atoms to help restore stability. Rutherford did his gold foil experiment, and afterwards he proposed the nuclear theory of the atom with three basic parts. So part one is that most of the atom's mass and all of its positive charge are contained in a tiny center core, which we know as the nucleus now. Number two, most of the volume of the atom is empty space, throughout which tiny negatively charged electrons are dispersed. So the electrons are tiny and moving around very quickly in a cloud around the nucleus, but in between the nucleus and the electrons is mostly empty space. Atoms are neutral, so that means that since we have these negatively charged particles, there has to be an equal number of positively charged particles to balance the charges. This is a diagram of Rutherford's gold foil experiment. So you'll see on the left, that was the previous model, which is called the plum pudding model. And so when Rutherford did his experiment, he expected that all of the alpha particles, which is what they were shooting at the gold foil, would go straight through. But what they actually observed is that a tiny percentage, about 1 in 20,000, bounced back. And so he proposed his nuclear theory based on the fact that it must have hit something that was positively charged like the alpha particles, because alpha particles are actually just 2 protons and 2 neutrons. It's the helium nucleus. So he proposed that they hit this positively charged dense nucleus of the atom. And so he came up with the new model. So this is the model with the electrons around it and the tiny nucleus that's very dense. Section 2.6, subatomic particles. Atomic mass units are defined as 1/12 of the mass of carbon-12. Because there are 12 particles in carbon-12, the mass of a proton and a neutron is approximately 1 atomic mass units. Elements are defined by their numbers of protons. So every hydrogen atom has 1 proton by definition. If it has 1 proton, then it is hydrogen. The atomic number is the number of protons of the atom in the atom's nucleus. The mass number is the protons and the neutrons together. So the mass number of a regular hydrogen, because it usually just has 1 proton and nothing else, its mass number would be 1. So it would be hydrogen 1. Isotopes are atoms that have the same number of protons but different numbers of neutrons. So here are 3 examples of isotopes of the hydrogen atom, and hydrogen is the only special one where its isotopes have different names. So we have just hydrogen 1, which is a regular hydrogen. This is the stable, most common form of hydrogen. It's just a proton and an electron. And then we have deuterium, or hydrogen 2, with a mass number of 2. And that is a proton and 1 neutron and the electron. And then we have tritium. So flash fans will see this is unstable, it's radioactive, and it has a proton and 2 neutrons with the electron, the one little electron going around in that s orbital that we'll talk about later. Section 2.6 continued. Ions are atoms that have gained or lost electrons to become charged particles. Cations are positive because they lost 1 or more electrons, and anions are negative because they have gained 1 or more electrons. This is a quick little introduction to oxidation and reduction. So we'll be going over this all year. But oxidation is losing electrons. So lithium here is being oxidized. It loses an electron to become lithium plus. So you'll see this is a metal, and it's lost its electron, become positively charged. So it's a cation on the right-hand side. And fluorine over here has gained an electron, so you're adding an electron to fluorine to make it a negative ion, which we call an anion. And the way that we can remember this oxidation and reduction stuff is oil rig. So picture an oil rig. We have the little setup with the oil squirting out the top, and it stands for oxidation is losing, like we're doing here, losing an electron. Reduction is gaining. So we're gaining an electron. So fluorine is being reduced, lithium is being oxidized. You won't be tested on the oxidation reduction, but you will be tested on these definitions up here. Okay, and then here's a cute little cat to help you remember that cations are positive. Conceptual connection 2.5. Which statement is true? For a given element, the size of an isotope with more neutrons is larger than one with fewer neutrons, or for a given element, the size of an atom is the same for all of the element's isotopes. If you said B is correct, if you said B is true, you are correct. For a given element, the size is not dependent on which isotope because the nucleus is so tiny. Most of the atom is empty space, and since they have the same number of electrons around them, they are the same size. So regardless if you have hydrogen 1, 2, or 3, they are the same size atom, just like we saw in our picture back here. So they're the same size, they just have a different nucleus. And the nucleus here is exaggerated by a ton. They would be a tiny speck that we wouldn't even be able to see there. All right, section 2.7, periodic law. The periodic law says when the elements are arranged in order of increasing mass, certain sets of properties recur periodically. So that means if we line all the elements up like they are right here, you should see a pattern. Okay, they've colored them according to their properties. So we have hydrogen is orange, and it has similar properties to fluorine and chlorine. Helium, neon, and argon, we know those are noble gases, so they all have similar properties, so they made them green. And then lithium, beryllium, and you can see these ones are kind of neutral-ish in the middle elements here. So we could rearrange these. You can probably do it in your head. How would you arrange them so that they are an increasing atomic number, but also in groups according to their properties? So you can see that helium, fluorine, and chlorine should be together. Lithium, sodium, and potassium should be together. And you'll have to look at the periodic table in a few slides to see how they're actually organized. There we go. So this hydrogen has similar properties to these gases over here, but it has one electron, so that's why they put it in group 1. So it's kind of off by itself. It has its own properties here. All right, so here is our periodic table. What you guys need to know is where are the metals, where are the nonmetals, and where are the semimetals, and what are their properties, which should be a review for you guys from Honors Chem. Okay, if you know the names of the groups, let me get my pointer here. So if you guys remember group 1, these are called the alkali metals. Group 2 is the alkaline earth metals. The way I remember that is this name is shorter and it comes first. The longer name comes second. So the alkaline earth metals come second. All in the center here we have the transition metals. And then we have on the right-hand side, so all the noble gases and these yellow elements, these are all the nonmetals. There's not very many nonmetals on the periodic table. It's almost all metals over here. And then we have these extra special ones that are this kind of beigeish color. And these are the metalloids or the semimetals, which have properties of both metals and nonmetals. And we'll see that on the slide coming up. Okay, so this is the gist of what you need to know for this Unit 1 test, which should be very easy. Where are the metals, where are the nonmetals, where are the metalloids? And remember the metalloids are right here in the center between the two. Between the metals and the nonmetals are the semimetals/metalloids. Okay, so the metals lie on the left and the middle of the periodic table. They are good conductors of heat and electricity. They're malleable, that means you can make sheets out of them. They're ductile, which means they can be drawn into wires. They're often shiny and they tend to form cations. Nonmetals are on the right side of the periodic table, and they vary in state. They can be solid, liquid, or gas, but they're usually poor conductors and they tend to gain electrons to become anions or negatively charged. Metalloids exhibit mixed properties, and many of them are semiconductors, which means they conduct at an intermediate level, and especially they're highly temperature dependent. So we use them for cell phones and computers and electronics because we can allow them to conduct or not conduct based on their temperature. So it's like a switch. It goes on and off whether or not they conduct. And silicon is a really good example of a metalloid that is a semiconductor. Hence Silicon Valley, where we get a lot of our electronics from. Okay, the main group elements are the S and the P block. So let's go back and look at where those are at. This is the S block right here, groups 1 and 2. So these are main group elements, and the P block is over here on the right. So this square right here, the P block, and the S block are called main group elements. Okay, those are our main group elements. A family or a group is a vertical column. So we have the alkali family, the alkaline earth family, and then a period is a horizontal row on the periodic table. I want you guys to look at the diagram and see if you guys find a pattern with the elements and the charges that are visible here. So we have group 1, you can see they're all +1. Group 2, these are +2 and they exclude this top element. Over here, it's just aluminum, but it is in group 3A and it does have a 3+ charge. And then you'll see I added zinc. Zinc always has a +2 charge and it's conveniently located next to aluminum. So this is +2, aluminum's +3. And then you can see over here we have -3, -2, so almost all of group 6A is -2, and 7A is almost all -1. So a little trick to help you guys remember those is what I call the charge clock. So inside we have the group numbers, and outside we have the charges. And down here, you notice that these don't work very well. If I go back to the +3, -3, and there was no plus or -4, but there's only one -3 and one +3. So it doesn't work for most of these. It only works for some of them. But the 2s and the 1s, it works really well. So group 1 is going to be +1 charge. Group 2 is going to be +2. Group 7A, or 17, also sometimes called 17, is a -1. And group 6, or 16, is a -2. Okay, so this is just to help you remember that. And that's it for section 2.5 to 2.7.